Good morning, everyone. Thank you for joining us this afternoon. I'm Ashley Skitt, Director of Marketing at Tempo Communications. Welcome to our webinar, Locating Irrigation System Wires, Valves, and Faults. So today your presenter is Alejandro Aste-Nieto. He is the Associate Product Manager of Irrigation and Location here at Tempo. And Hondo, as we like to call him, strives to gather voice customer insights for irrigation's electrical troubleshooting tools. Drawing from his experience in tech support here at Tempo, Alejandro possesses an understanding of irrigation system faults, tool tester functionality, and troubleshooting methodologies. He's committed to continuous learning, having attended various trainings from experts in the fields of irrigation and conducted several of his own, I will add. So without further ado, I will turn things over to Alejandro.
Thanks so much, Ashley. Thanks everybody for being here. We're going to talk about locating, something that is near and dear to me, something I've been looking forward to talking about. Pretty fun topic. We're going to be getting into some wire and valve locators. We've had the 521A for about 20 years, a very well-known locator. And we just recently launched an improvement on the 521A called the 521E. So we'll just be talking about both of those. They're used very similarly, and we're going to talk about how to set them up, and then how you're going to be tracing the wire path, how to find faults with these, how to determine the depth of the wire that you're locating valves, tracing two-wire cable in particular, some of the nuts and bolts as to what's going on with these locators, and then we're going to touch on a couple of the locators that we offer, the 501 Tracker 2, and then our EML 100, which is a marker locator, and the markers that it can find, as well as the PE 2003-G. It's the pulsar ground fault locator, so that will find faults in your wiring. So we'll talk about how to set that up, how to narrow down fault, and then how to verify that you've found the fault. I'm going to try to go through this pretty quick so we can wrap up and leave time for questions all within the hour. But yeah, if anybody has questions, feel free to ask away. So in order to use these, in order to locate successfully, it depends on a lot of factors. So for one thing, you need to use the right equipment and make sure that it's well maintained and in working condition. You need to understand that the soil condition affects how you're going to be able to locate. So moisture content is going to be a big factor there. The condition of the wiring and all the splices and devices there are going to have an effect on how your locator works. But first and foremost, you have to understand how to use the equipment in order to locate successfully. And this depends somewhat, so yeah, successful locating depends somewhat on the equipment, but mostly the understanding of how to use it. So that's what we're here to talk about today. The 521A and the 521E, these are designed for irrigation specifically. It's frequency, and that's beneficial because it reduces signal bleed to other wires. When you have a sprinkler system and you got 50 valves, and you need to find the location of one valve, you need to limit signal bleed as much as possible. Low frequencies in terms of locators are helpful for that. This particular, both these locators use 1.75 kilohertz. Things can go up to hundreds of kilohertz on the higher end. So this is on the lower end for locators. It also has a reduced signal bleed to ground, meaning it will give you a further signal along these wire paths. Higher frequencies tend to diminish quicker. It has a null antenna in the receiver, which gives you more of an exaggerated response at a solenoid. So that's obviously helpful for finding valves. Not only that, but it's more sensitive to other things on your wire path. So that might be faults or splices. So for that reason, null antennas are very helpful in irrigation systems. So the 521A and the 521E are capable of locating the wire path. You can use it to determine the depth of the wire. You can find solenoid valves. you can find breaks in the wire as long as you understand what you're looking for and have some experience in finding these. And same with nicks in the insulation of a wire. And we'll talk about kind of what to look for there. So setting one of these up, you want to start with your transmitter off for sure. Hook the red lead to the valve wire and the black lead to earth ground. So that's going to be a ground stake. So here's what it'll look like. You want to disconnect whatever valve you're looking for from the controller. You also want to disconnect the common wire from the controller. And then you're going to connect that red lead onto your target wire there. And then as far as establishing earth ground, you're going to use a ground stake. All these locators come with a ground stake, but you can use a screwdriver or whatever kind of metal spike you have. And placement of the ground stake can change your results. The best place to start is 2 to 3 feet perpendicular to your wire path. But moving the ground stake around can sometimes give you different results. Sometimes it'll improve your locating experience. You might, if you're inside a garage or basement, need to run a wire to get outside to where you can plant a ground stake. You don't want to use things like water pipes or the ground lug of an outlet. That will steal some of your signal. You might get readings off of things that you're not looking for if they're connected to other things underground. So in general, you want to avoid grounding things this way. And then next, we're going to turn our transmitter on once we've connected the leads. And what we're looking for is a mid-level reading on our gauge there. So by default, the 521E starts at level 1. The 521A has a manual knob so you can select, but you'll want to start low and then work your way high until you get to that mid-level reading. And once you have a mid-level reading, not only will that save your batteries versus turning it up higher, but it'll actually help in terms of the signal, because higher than you need is going to give you too much bleed onto other stuff, and it's actually going to distort the signal and diminish the quality of response on the wire that you're looking for. So if you can't get a good reading on that gauge, the most likely scenario is because there's not a great ground happening. One thing you can do to improve that, if you're in a dry, sandy condition, is to pour water on that ground stake. Salt water is actually ideal because it's the most conductive, and that will help you make a good ground contact. So once we do that, we are ready to get the receiver in our hands and go. Before we talk about kind of the wire path, the best place to start is just mid-level gain or sensitivity on your receiver and just kind of go from there. You'll want to leave headroom so that the signal that you're getting isn't maxing out on your receiver. You want to be able to leave room for other things like valves and hotspots. So as we're tracing the path, we're actually looking for a silence in between two high signal peaks next to the wire path. So the 521A and 521E have the null antenna, so you're always going to be looking for that silence in the middle of two big peaks in tone when you're following the path. So that tone, that null, will sometimes go away for one reason or another. One reason is there might be a cut in your wire, and what's going to happen is the signal is going to leave at the break in that wire, and it's going to create a little bit of a hot spot there where that break is, and then the signal is going to have signal won't be able to continue on the wire path, so you'll see the signal diminish very quickly at that point. Yeah, we mentioned that. So yeah, that's one great thing about the null is it's very easy to notice when it fades out, and pinpoint where the end of a wire is at a break. So just to kind of give us an overview of some of the things you might see in terms of signal intensity, you might see a little bit of a hotspot at a point where there's signal leaving the wire through a nick in the insulation. If there's a bad splice, again, the signal is leaving the wire into the dirt there and giving you a hotspot and in a diminished tone afterwards. A solenoid valve is going to be a huge response. We'll talk about why a little bit later, but that's going to be the most obvious thing to notice is a solenoid valve. Whenever there's a change in direction, it might do some funny things to the null because there's a round field around your wire, and as it follows the wire path, it will be kind of interfering upon itself. If there's a loop in the wiring underneath the ground, you might see more of a hot spot there and some funny things happening to your null. And then again, a break in the wire is going to be also pretty obvious in terms of hotspot in end of your tone there. So here's kind of an illustration of if there's just a nick in the insulation in the wire, you'll have a little bit of a hotspot there. So yeah, follow that null until that hotspot, and then once you pass that hotspot, the signal will get a little bit weaker as signal has left the wire into the dirt there. Some of it will continue on, but it'll be a little bit weaker. The bigger the nick, the more that effect will happen, the more there's a drop off in signal. In terms of being able to determine the depth of a wire, you can tilt the first you want to go vertical over the null and make sure that you're directly above the wire. Mark that spot, take a flag or whatever and plant it there, and then you're going to want to lean the receiver 45 degrees sideways to the path. So if your wire is coming in and out of the page here, you want to lean it to the left or right, and then you want that to be 45 degrees. Our 521E, the new locator, has a nifty little indicator that will confirm that you're leaning things at 45 degrees. And then at that point, you can drag it over in that direction that it's leaning until you find another null. Want to verify, that you have 45 degrees on the indicator and a null going at once. You mark that second spot, and the distance between those two spots that you marked will be the exact same, just because of geometry here, as the depth per spot. So if you have signal fading away for some reason, you don't really know why, one thing you can check is if it's because the wire is getting deeper, or if somebody piled a bunch of dirt over your irrigation wiring, and then you can verify the depth of the wire using this triangulation method. So when it comes to finding solenoid valves, first thing we can do is, again, you want to leave headroom on the signal of the receiver to allow for that big response from a valve compared to the path. And then that null will give way to a really big hotspot there. So that's an obvious way to find a valve. But if you have more than one hotspot and you want to make sure you are finding the right one, go back to the transmitter, shut it off, disconnect from that ground state, connect it to the common, and then return to your first hotspot. Get that the tip of the receiver as close as you can to that hotspot on the ground, and then make sure you have your sensitivity knob around mid-scale, but wherever it is, leave it there, and then go to the other hotspots and kind of compare the signal intensity and confirm with visuals which one's giving you the biggest one, and that valve is going to be the one that you're hooked up to. If you use this method to find valves, the reason why you don't want to do this step 2 first is because when you're hooked up to valve and common, those are going to be laid right next to each other, and signal coming and going is going to cancel what the receiver's picking up on. So it'll be a lot harder to trace wiring if you hook up to valve in common. However, there's still going to be hotspots over solenoids, and the one that you're hooked up to is going to be exaggerated. In terms of tracking with 2-wire, the way to do that is to hook your red lead to both of those wires in the cable, and then the other lead to a ground stake. That'll put signal onto both wires and give you not only give you the best signal, but it'll be safe for decoders because there won't be a difference in voltage across the 2 wires. The way to damage your decoders with a 521A or 521E is to hook up the 2 leads to those 2 wires in the 2-wire cable. That if you turn the transmitter up enough, will put damaging voltage across a decoder. So just make sure you clip onto both wires with the transmitter red lead and then the ground stake with the black lead there. So just to talk about some of the theory of what's going on behind all this stuff, the transmitter signal is, like I said, 1.75 kilohertz, just about, of alternating current onto the wires. That's coming out from the leads there. The alternating current is on the black and red. And so this is causing electricity to vibrate very quickly in the wire. And then due to what's called the right-hand rule, it causes the magnetic field around the cable to sort of rotate in a wiggling fashion at 1.75 kilohertz. And the closer to the wire, the larger that wiggling effect in the field will be, and the more your receiver will respond. So in terms of the receiver, both of these, like I mentioned, use a null antenna. So that's a cylindrical little coil of wire in the bottom of the pole there, and it's sensitive to the wiggles in this field. The way in which it's sensitive is movement in the field across that coil. So that means the orientation of the cylinder is going to determine how much signal it's going to be picking up. So if you turn the receiver in different orientations, you'll get different amounts of signal. So think of it in terms of a hurricane spinning around the wire. The winds are going to be fastest in the middle, right around here. And then picture that your antenna is kind of like a wind tunnel. It's got a turbine inside, picking up the speed of the wind going through that tunnel. And if your tunnel is oriented to catch the most wind, it's got to be parallel with the winds going around the wire. So the more aligned it is in that way, the more of that wind it's going to catch, the more signal it's going to catch. That's why on our 501 locator, we have this little cylindrical antenna perpendicular at the end there. It's going to catch the most of that wind right over the wire. So if we rotate the wind tunnel more and more towards the eye, it's going to get less and less wind blowing through it until it doesn't catch anything. It's just going past the wind tunnel, no matter the wind speed. So that's why you get a null when you're pointing at a wire. The orientation of the antenna is such that there's it's not listening for anything moving in that kind of a way. So solenoid valves also have these coiled wires inside, which actually concentrate the signal above and below. So when you have an antenna just above it vertically, it's going to get concentrated signal up in there to get a very exaggerated amount of wind, you could say. So that null antenna is going to be ideal for detecting valves for that reason. As you can see, the null will give way to a hotspot where the wire is connected to a valve. So hopefully this isn't too confusing, but this is looking at the wire going in and out of the page there, and this is a side-by-side view. So to the left and right of the wire path is where the signal is. Directly above is the null. But then once you get over the solenoid, that null gives way to a big hotspot and signal. And the AC from the transmitter requires that we make a circuit, signal leaving from the red lead, going out into your field wiring, and then returning onto the black lead. The simplest way to close that circuit is to connect with the valve wire and common wire. But like I mentioned, because they're laid right next to each other, the signal going and coming is going to cancel. Those right-hand rules, if you look at things clockwise one way and then you look at things clockwise the other way, they're going opposite directions. They're canceling the same. So the best path for signal to take, therefore, is to go through your wire and then back through the dirt at the starting at the far end of the wire, since this can kind of spread out in the dirt and create a strong circuit where cancellation is circumvented, and it's concentrated in the wire and then spread out through the dirt. So this is kind of thought-provoking, though, because there's no pre-existing grounding happening at the far end of any irrigation wires. They go out to a solenoid on the common wire. So how do we get grounding anywhere at the far end? Well, luckily the wire is bleeding off little bits of signal along the whole way, and it's sort of grounding capacitively. It's returning from the wire where it bleeds off back to the ground stake of the transmitter. That's the easiest way for the circuit to go, is through the insulation of the wire, which is acting as a little bit of a capacitor, which AC can pass through at higher and higher frequencies. So little bits of signal are being lost along the way, creating their own little circuits everywhere along the way, leaching off the signal via capacitance. And a long enough wire buried in the dirt is going to be grounded via that capacitance. So a wire laying on top of the dirt will not carry signal nearly as well unless you actually ground it at the far end. If you strip the far end of it, wrap it around a screwdriver, and stick it in the dirt, that wire's going to have no problem carrying signal, because now we have full circuit. We have wire going out through the wire, returning through the far end where it goes in the dirt, back to our ground stake. Hopefully that's not too confusing, but just sort of the theory of kind of how these operate. So to that point, our 501 is a little bit different in terms of how it works, in terms of its frequency, which is much, much higher. It's 450 kilohertz, just about. We got that peak antenna, that little perpendicular antenna down there. In terms of irrigation, it's actually really good for, really helpful for tracing 2-wire cable. The high frequency, you need less voltage to push it. So it's kind of a little bit more foolproof in terms of being damaging to decoders. But with multi-wire systems, it's not great because it's got so much signal bleed due to that capacitive effect and that high frequency. Obviously with 2-wire, that's not as much of a concern, because those are just the 2 wires, and there's not going to be any wiring laid next to it unless there's other paths branching out from there. With that 501, now that you understand the orientation of the antenna, you can use that same 45-degree method to look for a null and determine the depth of a wire. So same triangulation method can be done with the 501. This also has a couple of other methods of connection that the 521A doesn't. The 521A and the 501, you can directly connect with the alligator clip test leads, but with the 501, you can also use that inductive clamp that you see there on the left around a wire. The preferred method is always going to be directly connecting to get signal onto a wire, but sometimes the clamp is helpful. The last resort is going to be using the inductive antenna inside the case. You place the case down over whatever you're trying to locate. It'll catch a little bit of what the case is throwing down there, and you'll be able to trace. So 501's got a couple other nifty features that might be helpful in irrigation. And we also have an electronic marker system. So the locator we have is called the EML 100. And this could be, and so this works with our buried markers here, our marker balls, which work up to 5 feet deep, and our spike markers, which we've just released, which are much more compact, but still work up to 3 feet deep. And this could be helpful in irrigation for a couple of reasons. We primarily sell these to utilities. They're kind of more concerned with what's buried so that they can dig safely and not worry about hitting something. But in irrigation, you can mark things of interest as well. So valve boxes, pipe joints and fittings, pipe ends, sleeve ends, crossings, whatever you want to mark and be able to come back and confirm later. So this is a system that's potentially useful for irrigation as well. So onto before I go into the fault locator, I guess I'll just kind of pause and give people a chance to ask any questions if they feel the need. Otherwise, we can wait for the end. But all right, yeah. So let's get started here on the P2003-G. So the way this works, it sends a short burst of high voltage, 3,400 volts of DC, and that A-frame and receiver will be able to detect where that voltage is leaving a cable or a wire into the ground, and we'll be able to pinpoint it very accurately. So shorts to ground, it'll find if there's a clean break in a wire, even if there's a tiny little nick in the insulation, it will find the stuff starting with the largest fault, giving the strongest signal. And then once that's been repaired, you'll be able to find the biggest fault, the next biggest leak in. But just know that this does not locate the wire path, and you're going to want to know the wire path when using the ground fault locator, or else it's going to be very difficult to pinpoint a fault. Not only that, but the fault has to be making contact with dirt. So for any wiring that's in a conduit, that conduit is just blocking the signal at the fault. So just keep that in mind. So before we get started with the fault finding, like I mentioned, we have to trace the cable path with your 5, for instance, and make sure you mark it appropriately. At that point, we have to isolate both ends of the wire that we're find a fault in for a couple of reasons. We for one thing, don't want any damage to be happening to whatever's hooked up to these wires. But for another thing, you want all the voltage that they can possibly get to leak out through the fault. And if there's anything else connected, like controller, obviously that's damaging. But even valves and decoders, you'll want to be disconnecting so that voltage doesn't do any damage or go somewhere other than the fault that you're trying to find. You want to make sure that you're not making ground contact on either end of the wire, or else you're just gonna be picking up the end of the wire. And disconnect the common from your controller just in case things are hooked up in a way that you didn't predict. You don't want all that voltage coming back to your controller. So setting up the transmitter here, it comes brand new with a fuse outside so that you don't accidentally turn the machine on. So with that fuse, we're going to slide it into the little cap here, and then it takes firm push into the sleeve and then a quarter turn clockwise to lock it in. It does not screw on that. If you attempt to screw this thing, it's just going to break the fuse cap there. So you typically want to have the transmitter charge overnight before the first time you use it. And anytime you do use it, you want to keep it topped up for that battery to keep it in good condition. One thing we can just do to test the battery is turn it on, make sure you don't have anything near the leads, of course, but if it's got a good, strong sounding tone coming from the transmitter, that indicates you've got a good battery charge. If it's a scratchy kind of a hissy kind of a sound, that means it probably needs a charge, or if it doesn't make any kind of sound. The receiver runs off of a 9-volt battery, so you take these screws off of the sides here to open up the battery compartment, install the 9-volt, close it back up, and there's a little test we can do. We have to switch this from the off position. Doesn't matter how far we turn it up, but just click it over a little bit, press this button, and this turns into a battery indicator. It will slide over to here to indicate a good battery. And then the receiver just mounts to the A-frame here with a couple thumb screws from underneath. And then we have a couple of leads to install onto the back of the receiver here. They're color-coded black and red, so hook the black lead to the black. We got a little echo out there. I think somebody might need to mute.
Yeah, please everyone go on mute.
So yeah, there's going to be a little black plug, just hook black to black and red to red. And so now we're going to hook up our black to a ground stake, again, not to a different kind of ground out there. And then again, ideally just 2 or 3 feet off to the side of your wire. And then red lead will go to your faulted wire. And then again, just a note on 2-wire stuff, connect to both wires, and then you'll be able to find a fault on either wire. And if there should be a decoder out there, this is the best way to mitigate any chances of doing damage also. Next, we can turn the transmitter on and it'll start beeping and away we go. So the way we're gonna try to find a fault here is we're gonna advance out towards the fault and we're gonna take note of where the needle is kicking and telling us where to go. So we have the receiver on the A-frame here, and we're probing into the ground right above the wire path, just next to it. So the A-frame probes are parallel to the direction that the wire is going. So there's going to be a big kick at first when you're near the transmitter, basically telling you to get away from the transmitter. And it's always the direction of that first kick that you pay attention to, because it'll swing very hard one way, it'll recoil and go back the other way. Some people get kind of confused about which one to pay attention to. It's always the first kick, which will occur at the same time as that beep from the transmitter. So we're going to follow that kick until the kick of that first movement reverses direction. So the kick, like I said, next to the transmitter, it's going to be pretty strong since you're right next to the ground stake. It's collecting all the leaking voltage that happens out in the fault, and your A-frame is picking up on that. But as you get further out into the field, you're getting away from the ground stake, and you might not necessarily be close to the fault. So you might not see any movement on the needle on the receiver. You just have to have faith that the A-frame is eventually going to get into range of 3,400 volts of DC is going to have no problem going really far along a wire and exit out at a fault. So the distance of the fault from your transmitter is really not going to be a concern. There's just so much power going through it. It's gonna the transmitter is going to be strong enough to to put voltage out through the fault. The A-frame, however, doesn't have infinite range. It has to get maybe within 100 feet, maybe in best case scenario, 100 yards from the fault before you start to see a little wiggle on the needle. Again, this all depends on soil conditions, the size of the fault, the depth of the wire, so a number of things. As you approach the fault, you will start to see the kick yet again. It'll get stronger as you approach the fault until it reverses. And obviously that indicates the points at which you took those last two stops with the A-frame. The fault is somewhere in between those, and you can keep narrowing down that area. So you just move, halfway to the last spot, see which way it kicks, move halfway to that direction until you might get a perfect null on the needle. Some people kind of get hung up on looking for that perfect null when all they do is move the A-frame half an inch and the needle reverses direction. You've narrowed it down to a half an inch area, so don't worry too much about getting the null, but sometimes you'll see a null in the needle when you're perfectly on top of the fault. These A-frames are super sensitive to a square inch of where the fault is. You'll know exactly where to dig. At this point, we have to confirm that we're not off to the side of our wire path by a little bit. So rotate 90 degrees, and you might see that it kicks a little bit to the left or to the right. You can kind of narrow it. Do this until you can completely confirm that you're exactly over the fault. You can mark that and know exactly where to dig. Something we can do to just sort of verify that we're not off is just stick one of the probes of the A-frame in the ground where you've marked the fault, rotate the other probe 90 degrees 4 times, and you should see the needle kicking towards that same probe in the mark for the fault all 4 times. The reason for this is you might see a false reversal depending on the cable path. So if the cable path sort of swoops this way, you might be following it here, see a needle kicking this direction, and then your fault is here, but your needle reverses this way because now this probe is closest to the fault, and it's giving you a false indication. So turning the A-frame will help give you a clue as to a false reversal there. And then for 2-wire, again, clip to both wires and ground stake. This will, again, just be a precaution in case anything is still hooked up to the 2 wires, and it will make sure that you're finding a fault on either one. But again, the safest thing to do is to just disconnect the next opportunity, basically. So again, for all locators, just remember, it's all about expertise and understanding the equipment. The equipment can't do everything for you. So just keep these things in mind. Oh, I just had some funny images there. So summary, the 521A, 521E wire and valve locators, they're low frequency. They use a null antenna. You're going to want to follow the cancellation and signal between those 2 peaks on either side of your wire path. And then disconnect that zone wire and the common from the controller. You're going to want to use a ground stake, not a water pipe or anything building. Make sure you have the receiver gain with plenty of headroom so that you're able to find any anomalies along the wire path. Solenoids are going to give you the strongest response. Some other hotspots are going to be loops in the wire, breaks, splices, etc. And then to determine the depth of the wire, it's going to be that 45-degree trick. So first we go vertical, mark where there's a null, tilt it 45 degrees off to the side of the wire path, drag it over in that direction until you have another null, verify 45 degrees, That distance is the depth of the wire there. P2003, just make sure you isolate everything on both ends of the wire section that you're trying to find the fault in. Use the ground stake. The fault is going to be in the direction of that first kick on the needle, and it's going to start with finding the biggest fault and going from there. One thing I didn't mention that's a nice little trick about the P2003 is that you can use it to find faults that are under asphalt even. One thing you can do is soak some wet sponges in salt water, stick those on your spikes, put those onto the pavement, and it will still be able to kind of sense something under the pavement there. Other thing you can do if there's like a narrow section of sidewalk is tie some wire to a ground stake. The other end of that wire, tie it to one of your two spikes on your A-frame. You've now basically moved one of your spikes on your A-frame to wherever that ground stake is. So you can kind of spike on either side of a sidewalk and picture just a bigger A-frame. And if it's telling you kicking to the left or right, it's giving you an indication of where that is. So at this point, we'll open it up for any questions that there might be. In general, in irrigation, null is more helpful just because it is more sensitive to anything going on underneath you, and it's going to have a more exaggerated response with a valve. So if you have to pick one or the other, null is going to be it's going to be more revealing in what's going on. It's a little bit less intuitive. It's rather than looking for the strong signal like you would with a peak antenna, you have to follow the silence and kind of understand what's going on there. But it's going to tell you more. It's going to tell you more information most of the time. Ideally you can have kind of both things to compare, but the peak antenna is sort of going to light up in a broad area over the wire, and it's and if we picture kind of a wind tunnel in a hurricane, it's just going to be a lot of wind no matter where you are at the edge of the hurricane if you're pointing it that way. So in general, null antenna is going to be a little bit more helpful in irrigation.
I have another one. I'm having trouble getting a good signal with my valve locator. Why might this be happening?
Okay, so the first thing to check is probably just the ground stake. If the ground around it is dry, or if it's rocky or something like that, wet that or move the ground stake. There's an indication usually on the meter, on the gauge of the transmitter, kind of telling you what's going on. If that's low, that means it's having a hard time making a circuit through the wire and then back through the ground stake. So it could be that the ground stake is the weak point there, but it could be that the wire that you're tracing is actually faulted pretty near where you're hooked up, and there's not really much of a chance for it to create any grounding. If you're looking for a valve that's right nearby and the wire that you're tracking is not spliced correctly to that valve, and it's just a short run and there's no grounding happening at the far end, there's going to have a hard time doing its job. So that's another thing to consider. And then, just ground stake and short run of wire are probably going to be the two most common situations.
Okay, thank you. And then we have a technician that said they work with multi-wire and 2-wire systems. So for that, what would be the best locator to use?
Yeah, for that, I would still recommend 521A or 521E. Like I said, it can be used on 2-wire just fine when you hook up to both wires. And feed from the 501 is going to be frustrating for use with multi-wire. So if you're doing exclusively 2-wire, you can probably kind of take your pick. But if you're working with multi-wire at all, the 501 is not going to be as helpful for sure.
Great, thank you. And I love the extra tips at the end with the PE 2003 and the cement. That's awesome. So again, if no one else has questions, thank you so much for your time today. Thank you, Alejandro, for the awesome information. And we'll see you again. Don't forget, in 2 weeks, we have the last of our 3-part series. So be sure to join us. Thank you, everyone.
Thanks, everybody.